Number 4 says to factor x squared minus 13x plus 30. Okay, again, first you're going to say if you have a common factor, which we do not. Then notice if you begin with x squared, if we want to break this into two polynomials or two binomials, it will be x times x. Look at your last number, positive 30. This sign still means that we need to find two numbers that multiply to be 30, but add to be negative 13. Okay, if that is positive, it still means you want to find the two numbers that add to give you the middle term. So if I again make a list of all the factors of 30, 1 times 30, 2 times 15, 3 times 10, or 5 times 6, okay, which two numbers would add up to be 13? Okay, it would be 3 and 10, but what would their signs have to be? Okay, if it needs to add up to be negative 13, then both of these numbers will need to be negative. So in my answer, I would have x minus 3 and x minus 10. Okay, so again, if the last sign in your polynomial is positive, which it is, the signs in your answer will be the same. Okay, but they will be the same as whatever sign is in the middle. Okay, so as you're looking and you say, what's going to multiply to be 30 and add to be negative 13? So those signs have to be the same if you're going to be adding the numbers. Okay, again, you can check these if you want to by doing the FOIL method. If I check, x times x would be x squared, x times negative 10 would be negative 10x, negative 3 times x is negative 3x. Negative 3 times negative 10 is positive 30. Combine like terms. And so I get the exact polynomial that I started with. Okay, your answer should always multiply back to equal what you started with. But your answer for this would be x minus 3 times x minus 5. Okay, let's look at number 5. X squared minus 15x plus 56. There's no common factor. If I'm beginning with just x squared, then I'm going to have x times x. I need to look at the last number as a positive 56. So I want to know what two numbers will multiply to be 56. 1 times 56, 2 times 28, 3 will not go into 56. 4 times 14, 5 will not go into 56, 6 times 9. Okay, I want to know what two numbers from that list are going to add up to be negative 15. Okay, well the numbers that add to be 15 would be 6 and 9, but they both have to be negative in order for it to be negative 15. So I would have x minus 6, x minus 9. It does not matter the order that you write those two binomials in. It could be x minus 9 times x minus 6. Okay, either one would be your solution. Okay, number 6, we have x squared minus 10x plus 21. There's not a common factor. I'm beginning with x squared, so I'm going to have x times x. Look at the constant. I have 21. Positive 21 means I want to find two numbers that will add to give me 10, okay, and multiply to be 21. So 1 times 21 or 3 times 7. Okay, which pair will add up to be negative 10? So that would be 3 and 7 if they are both negative. So x minus 3, x minus 7 would be my solution. Okay, whenever you make your list over here on the side, there will only be one pair of numbers that will work. Okay, so always be careful as far as looking at your signs and deciding, which ones am I going to use. If it's a huge number, there's still just going to be one pair that will work. Okay, if you have a problem where you can't find a number that works, okay, let's look at that. If I have something like x squared minus 7x plus 3, okay, there's not a common factor, and so I wouldn't have to pull out a GCF. I try to break it down. X times x, I look at the last number. Positive 3 means I have to find two numbers that would add to be negative 7. Well, if I look at positive 3, the only factors are 1 times 3, and that will not add up to give me 7. If this is the case and you don't find a number that works, it means that this polynomial cannot be factored. And so if a polynomial cannot be factored, we say that it's prime. Okay, so on your homework, you'll be given that option. It may say if the polynomial is prime, you would type N, or a P for prime, N for no solution. Okay, those are pretty rare. I don't like to give a lot of ones that are prime, but you do have polynomials sometimes that cannot be factored.